We've been working on writing functions. So what I'd like to do today is practice writing a couple functions just by way of review. I want to practice calling them, and then I want to practice binding them. Our last lesson, we bound functions to a keyboard. And today we're going to bind functions to a mouse event. And it's got a little bit of a trick to it, but we'll get used to it. So I've got a project that I've opened up a new document. I've called it mouse_binding. And let's start by writing a function. And I want this function to get the area of a rectangle. So I'll just call it getArea. And we'll say length, width, colon. Now, how do you get the area of a rectangle? Multiply the length by the width. So let's say return. We have to say return or it won't do it, right? Length times width. Well, we could print it. We could say this. We could say print, and then it won't return it. It'll just print it. We can do that. Let's start with that actually. Let's write another function called def get perimeter, and a rectangle again has a length and a width. So we use functions to allow us to call certain amounts of code over and over and over again quickly and easily. So the perimeter well, you have to multiply the length times 2 and the width times 2. All right, so I have under view, I have my variables turned on. And I think that's a nice way you can see how this works. So we ran the module. So I clicked on the run module, and hopefully you don't get any errors. And if it works correctly, you should get some new values here. So we have created, it says function called getArea, and it says @. Now this is what's called a hexadecimal number. So we're used to numbers that count with digits 0 through 9, but we can also use the letters A through F, and we can have a base 16. We'll learn about this more later. But this represents, you can think of it as the location of where this function is stored in the computer. It's not exactly like that in Python, but it works pretty much that way. So we now have access to those functions. Let's practice calling them in the interactive shell. That's down here. So let's say getArea, and let's test it. What would the area be of a 10 by 15 rectangle? What should it be before we hit enter? 150. And you'll notice that it's printed 150 right here to the terminal. Okay? Let's try get perimeter. And let's do that as well. Now that should be 20 plus 30, so that'll be just 50. So let's look at the difference between the two. The getArea did not return, it printed. Get perimeter returned. So do you see the difference between the two here? Well, this is just printing. There's nothing I can do with that now. It's printed. But this is an actual value that I can keep. So, for example, I can say P equals get perimeter 2, 5. The perimeter of a rectangle with sides 2 and 5 would be 4 plus 10 is 14. And you'll notice I now have P as a variable 14. So what about the area? Can I do the same thing with the get area? Let's do 2 and 5. Again, that should be an area of 10. But look what happened. What does it say is stored in A? It says none. That's because we didn't return anything we printed. So for those reasons, it's best, instead of printing, that we return. Now we can put parentheses around it like we do with print. No, we don't have to. So I'll take them off. I'll run it again. And I just right click here and hit clear whenever it gets too full. And so now I can do stuff like print. Let's say I had a rectangle called rect, and the length was equal to 10, and rect W had a width equal to 20. Then we can print get area rect L, comma rect underscore W, and I know I'm typing fast, but I'll slow down. Get perimeter now you don't need to hit enter here. I just did that so that you can see, okay? In fact, I don't know. It might even error on me. So don't hit enter where I did. I just have a really big font. Okay. So you can see right here that we now have 4 variables. We have a get area, get perimeter. We have a rectangle length, rectangle width. And we're able to put those in our functions and use them. And the print function is separating each one by a space. Okay, so when you're done filling in those methods and practicing, I'm going to give you a little mini assignment. I want you to write a function called get CER for circumference, and get area. Well, we'll have to spell it different. Let's call it. I'll tell you what. Let's call it circ area and something like that. Let's try that. So I want you, when you're done with this, to write def. Actually, you know what? We'll just clear these out. You can make a new one if you want, but this is just for practice, so I'm just going to delete them if that's okay. And let's say def get area of a circle with a radius, and I want you to do get circumference given a radius. So write those right now, and then we'll go over them. All right, let's go over it. So the radius times pi, or the radius squared times pi will give us the area of the circle. So I'm going to return, I'll say 3.14 times. Now I can just say radius times radius, that would square, but the square in Python is times times. So radius times times 2, that's how you put something to the second power. The circumference is pi times 2 times the radius. So one time you multiply the radius by itself, the other time you multiply by 2. And let's try. Let's try print. Oh, we gotta load the module though. So run it, hit this green button, and you can see we have our functions here now. And we can print get area, let's do a radius of 10. And we can compare that to the circumference of a circle with radius 10. So remember, the print function can have 2 parts. or even 3 parts, there's each part separated by a comma. It will print this part, and then it'll put a space, and then it'll put that part. You can tell it to print as many things as you want. And there you go. Now, don't let it bother you that this has a bunch of zeros and then a 4. Python is, without us telling it to do something else, Python is not accurate in the last decimal place. That's just because we usually don't care. And we can always round our answer. We talked about that before. There are math values you can get that are exact, but they take more memory and time, so we usually just use these. Let's use a for loop to see what happens to the area of a circle. So I'm going to do for I in range, let's do 0 to 101 by 10. Actually, you know what? Let's start at 10. So remember, the range function starts at this number, stops when it gets to that number or beyond, and this is what it counts by. Colon, and let's do it. Let's say print get area I get circumference. And so if we were doing something like this, we're going to use a loop. We're going to be looking at several different numbers, and we can compare the effect of the radius growing on the area compared to the circumference and see which one it has a bigger effect on. And I think you'll see pretty quickly that while the circumference grows a little bit, right? The radius grows by quite a bit. And that's because of the squaring versus the timesing by 2. And again, if you don't like these ugly decimals, we could round this, of course. Mm-hmm. All right, so let's just clear all that out, and we can move on to what I want to do after that little warm-up on functions. But it's been a little while, so it was worthwhile. So at the top of your page, I want you to say from turtle import, and let's go ahead and import everything just for easiness, okay? So if we run this right now, you'll notice that it loads up a bunch of variables and functions. We have all these functions and, of course, our class. So today I want to be looking at a couple of different methods. The first one I want to do is I want to look at this method, this function here called onClick. Okay? So we're going to be looking at the onClick function. So let's say def. Def is short for define. And we're going to do several things. So let's try say hi. And then I want you to give it an x comma y. And then say print hi. And I'll explain the x comma y in just a minute. The next thing that we're going to do is we're going to define a main function. The main function is the function that controls our program. So code is read from top down. But code can also be put together inside packets. And these packets are functions. And the main function is the first function that will be run. Okay? So def main. And here's what I want to do. First of all, I want you to say shape turtle. To set our, we'll be using the default turtle, not a turtle object. We'll go back to those later. Let's go ahead and make our turtle pretty fast. We'll give it speed 0, which is almost the fastest you can do. And I want you to say on click, say hi. And then you can backspace over. All right, so on click is a function that means when you click your mouse on the turtle. We do have some customization that we can do as well. We can actually set which button we press, but since I didn't set it, it's going to default to button number 1, which is the left button. If you recall from our last lesson, this is the one and only time that you don't put parentheses after a function. And we talked about how we had to have a function without any parameters to be bound to a keyboard. However, this time we had to have an X and a Y. And the reason why is because all mouse clicking events in the turtle module automatically send the X and Y coordinate of where you clicked. And we're going to show that in just a second. Let's run this puppy. Oh, actually, let's not. We'll say if underscore underscore name underscore underscore equals equals quote dunder name dunder. Dunder stands for double under. So we have that at the very bottom of our code so that the entire module is loaded first. Then the very last thing we'll do is we're going to ask Python, did they press the green and white run button on this module? If they did, run main. So I guess in reality, this is actually where your program starts. It's running and loading everything until it sees this. Once it sees this, it's going to run main. That's why it's important we had this at the bottom, because if we had this at the top, we would only have access to things that have already been loaded. So let's run and see if it works. Well, oh, if name equals main. Yes, I'm sorry about that. I was about to say, nothing happened. All right, yes, please make sure it says if name equals main. Okay, so I have mine over here. And I'm just going to click on my turtle. I can click everywhere I want, but if I click on the turtle, it says hi. That's right, it's very cute. All right, so that is the on-click function. And we have bound it to our turtle so that when you click on the turtle with the mouse, it does that. Okay? Now, I would like for us to write something a little bit different. I want us to add a function that we can call with the right click. And I'm going to call this function runaway. So I want you to call this function runaway. And we'll be calling it on a mouse click, so we'll need X and Y, even if we didn't use them. So what I want you to do is I want you to turn left 60 degrees and then go forward 100. So whenever we call the runaway method, wherever the turtle is, that turtle is going to turn left and run 100 pixels. Now on the print, I want us to go back and I want you to say hi from, then I want you to hit comma, X, comma, Y. And so that way, we'll actually get to see where our turtle is when we click on it. So we have two new we've edited say hi, and we've got one new function called run away. So the only thing left to do is to bind run away. Let's bind run away to the right mouse button click. So again, we don't put the parameters to call the parentheses to call it, but I want you to say btn equals 3, so that it knows that that's the added customization that we're adding to say, I don't want it to be a left click, I want it to be button 3, which is actually the far right mouse button. The scroll wheel, the clickable scroll wheel, is button 2. Then when you're ready, you can run that. And now it tells us where our turtle is when we click on it. Now notice it's a little bit different depending on the part of the turtle I click on, because the turtle is more than 1 pixel wide. I'm going to right click on my turtle and have them start to run away. And you can see that the X and Y values are quite different. And if I keep right clicking on my turtle, eventually he makes a hexagon. And then if I say left click, he'll say hi. And we can kind of see the different regions of the word. You can see over here, I'm at a positive Y value, right? Positive Y, 92, and a negative X. That is because unlike almost every other computer science graphics paradigm I know, the turtle graphics actually follows your algebra pretty closely. The middle of the screen is 0, 0, positive X to the right, positive Y going up. Okay, so that is the on-click. Okay, so I want to do one more function that we bind to clicks on the turtle. One of them that's kind of an interesting function to use is the goTo function. The goTo function takes an X and a Y. So when I say like go to, let me just show this right quick. If I, y'all don't need to type this, just watch, okay? You don't need to type this. So I've got a turtle here, and what I want to show is this goTo command. goTo, I can tell it anywhere I want it to go to, like 100, 200, and the turtle will automatically go there to that XY position. So it automatically takes an X and a Y. So the goTo function is actually perfectly built in for us to use with our mouse commands. So let's go back and look at that. So I want you to go to our main function, and I want you to add one more that's going to be useful in a project we'll be doing. So I want you to say on drag, and I just want you to say goTo. So on drag means when you click and hold. And the goTo function automatically takes an X and a Y, and on drag, because it's a mouse command, automatically sends an X and a Y. So now when you select your turtle, if you click on him, he'll say hi. If you right click on him, he'll start to make the hexagon. But if you click on him and hold, he'll be able to pick him up and move him around the screen. Okay? And yet we still have our ability to do the different functions that we already have. And that's pretty much it, y'all. That's all the functions that we can call on this turtle, okay? All right, so that is all the different things that we can do to the turtle. Now I want to talk about binding mouse events to the screen. And the function that we use for that is, instead of on click, you'll notice that we have, if I can find it, should have on screen click. Oh, I've got this moved up. There it is. On screen click. Okay? And it's the same parameters as the other functions. You have to tell it the function to call, and you can tell it the button you want it to be bound to. We can leave these here if you want. That's not going to hurt, but I want us to make some new ones. The first one I want to do is look at. I'll just make it one word, look at. And automatically, every mouse click comes, every function called with the mouse click will send the XY location. Now, don't misunderstand me. I could call this X anything I want. These variable names are my choice. The parameter names are my choice. But since they are in an X and a Y location, doesn't it make sense to use X and Y? So now what I'm going to say is, I'm going to use another function from our turtle module called setHeading. So we're going to be using this function right here, okay? setHeading tells the turtle a direction to look. So we're simply going to say setHeading. But the setHeading takes an angle, okay? So I'm going to call this angle. All right? So first we have to get the angle. So move up a line, and I want you to say angle gets. There's another function we're going to use, and that's called towards. Towards returns the angle that your turtle needs in order to look at that point. The angles go from 0 pointing directly to the right, 180 straight up. 90 straight up, 180 is to the left, 270 down. You don't need to write this, I just wanted to show it. That's 90 degrees. This is 180 degrees. And then straight down is 270 degrees. And you could even say 360 and it puts you right back where you were. Okay? So that's how that works. And the towards function returns the angle that the turtle would have to rotate to look at it. So I get the angle called angle, and then I set the heading with that angle. All right. Oh, you know what? We just ran the code, but we forgot to bind it. Let's bind it. So I want you to go down here, and I'm just going to go ahead and delete these for now. I think you can leave them if you want. It doesn't matter. And I'm going to say on screen click. So the on screen click is the function for when you want to control where they click anywhere. Okay? On screen click, I want to run look at. All right, and let's run that. And now you have a turtle that stalks your mouse cursor. Well, you have to click, but yeah. Okay, we got just a few more to do. The next function that I would like to work on is I would like to make a function called runaway or retreat. We already did runaway. Let's do retreat. So def retreat, and we're going to be calling it with a mouse click. So we need to give it an X and a Y. All right. So the retreat. What I want the turtle to do this time is I want it to go to where you click and then turn around and look at where it came from. So you'll be like a captain or a commander, a military commander, and you're telling your troops, retreat there, and then they retreat, and then they can aim their bow and arrows or something at where they came from. Make sense? So in order to do this, though, I need to know where I used to be. So we're going to run to XY, but we need to know where we used to be. We know how to look at XY. That would be this code here. So again, we're learning lots of functions today. But if I go down my function list here, there's a one I want to use called XCore. And there's YCore. And that returns the X coordinate of the turtle, and YCore is the Y coordinate of the turtle. So I'm going to call it old X, and I'll say XCore. Now remember, all functions have to have parentheses. Sometimes they have parameters, like left, we had to put 60 to turn left 60 degrees. This does not have parameter because there's nothing to do. It's just going to tell you the X coordinate of the turtle. Then I want you to say old Y and say YCore. So old X and old Y are the X and Y coordinates of where we used to be. Then we're going to go to our new Y coordinates. So we're going to go to XY. Then I'm going to say set heading towards old X, old Y. Now, on the last time that we did look at, I did this last step in 2 steps, but I wanted to show you how I could do it in 1. The towards function tells you what angle you have to rotate for the turtle to look at these 2 coordinates that you put in its parameters. So towards is going to return an angle. And while it's returning it, instead of storing it in a variable, let's just put it right inside this larger function, set heading. So it'll work its way from inside out, parentheses first. So first it'll get the angle using that function, then it'll set the heading using this function. And I'm just going to go ahead and take out look at, and I'm going to change on-screen click to retreat. And hopefully we see our turtle go to where we said and look back at where it came from. And hopefully this is as cool as I remember. Oh no, I have an error. What's it say? Name error. Name old X is not defined. That's got to be a spelling error. And it is. I switched to lowercase. So let me fix that. And I will try again. And so you can see the turtle is always looking down the line from where it came. It has kind of a unnerving kind of way about it. Okay, so what we're going to do now is we're going to add the ability to change color. And there's lots of ways we can do this, but I want to use a change color based on where we click. And we'll use the middle mouse button. So right around here somewhere, let's say def change underscore color. And again, we'll be calling it with the mouse, so we'll need the XY. And I want to support 4 color choices. Red, blue, green, and black. And if we were to divide the screen into an XY plane, I want quadrant 1 to be black. I want quadrant 2 to be blue. I want quadrant 3 to be red. And then the last one here can be green. So let's see how we can do that. We can do that with if statements. So if the x is less than 0, that would be to the left-hand side of the screen, right? And y is less than 0. So if x is less than 0 and y is less than 0, then we know that we clicked on the bottom left-hand side, right? Because x less than 0 is to the left, y less than 0 is down below. And I want to set our color to red. Now, if they didn't do that, I want to give some more options. So I'm going to call it elif, as in else if. So elif x is less than 0 and y is greater than or equal to 0, I want to set the color to blue. Elif x is greater than or equal to 0 and y is less than 0, that would be to the right, but down below, which we said would be green. And then I'll finally just say else. Let's let the color be black. So remember, the elif stands for else if, and it will only happen if the previous statement was false. So if this statement is false, it will then check this to see if that, and if that's true, it will set the color blue, and then nothing else will happen. Else means if everything else before it was false, do this as a fallback. Let's set that to our middle mouse click. The middle mouse click is, let's do right mouse click actually. That's button 3. Right mouse click is button 3. So we'll go down here and we're going to say on screen click, change color, but we have to tell it a different button this time. We'll say button 3. If I didn't say that, it would stay at button 1 and it would just override the previous assignment. And so now right-clicking in different areas of the screen allows to have different shapes. Okay? Okay, I have one more function that I want us to do, and this one's a doozy. But I had this idea and it works. But it'll be a bit of coding. I want to use the middle mouse button to make the turtle make a circle that is got the same radius as the distance that we move to click. Okay? So that's what we're going to do. All right. So let's go to, we'll do it right here. We're going to call it def do circle. So I need to, again, keep track of my old x, okay? And so I'm going to use x1 for that. x1 gets x core. y1 gets y core. And I'll say go to xy. Okay, so we've got x1 and y1 is our original x coordinates from where the turtle was. And then we're going to go to the xy location of where they were clicked. Now, what I want to do is I want to get the distance from my turtle's current position to where we used to be. So dist equals distance x1, y1. So that will tell me how far away it is to the point where we used to be. Then I want to set heading towards where we used to be. So that makes us look at where we came from. And in order to make the circle right, we need to turn to the right 90 degrees. So do right 90. And then circle, and then we have to say distance divided by 2. Because we're giving the circle a radius, and distance is actually our diameter. In fact, they probably should have labeled it diameter. So let me go through this again. I told you this was a doozy. Wherever we click, that's where our turtle's going to go. First, I record in x1 and y1 the x coordinate and y coordinate of where our turtle was when we clicked on the screen. Then we go to the xy location of where they clicked. The distance function will then return the distance from where our turtle now is after moving to any xy I give it, so I'm giving the original. I then make the turtle look towards the original point and turn right 90 degrees so the circle is just right. Then I give the circle a radius, so I take my diameter distance and divide by 2. Then on the on-screen click, add do circle to button 2. And I think you'll like what happens. It allows us to middle click, and it makes a circle wherever you click that's just exactly as wide as where this turtle used to be. And you can do some pretty cool stuff there. All right, so that is all the turtle functions I want to go over today. We used a lot of them. I want to bring up something before we quit. If you Google Python turtle docs, you click on that first link, this is everything you can do, and it explains how to do it. We mainly deal only with turtle, and we've started to look down here at some of these screen event methods. And you can learn how those work as well. So, that's where they are. We can always find them when we view variables, but you have to make sure you run the module once for them to come up and learn how to use them. We used a lot of new ones today. And that's it.